Okay, so today's project, we're going to use the same project all the way through for this exercise. We're going to focus heavily on methods and how they work. So we're going to use a command line application to do this. So we'll say new and project. And we're going to use console application, making sure that Visual C# is the language there. If not, and you have multiple languages installed, you'll just go to the side here, look for your language, Visual C#, expand it, and then look for console application. We're going to call this one W2 ref params. Right, and you're going to give it a home. Okay. And I'll create a directory for my solution and add to source control. Alright, so we're going to start off with program.cs. That's our main program here, program.cs. It has static void main, it has class program, and we're going to get right into writing some code. So let's start off with just some really simple stuff that we were accustomed to in Java. We'll take it into C#. We'll see how it works. So for example, we can do like a simple int z is equal to 15, a float j is equal to 2.0, and we'll notice that 2.0 will give an error, and that's because it thinks that this is a double. Even by mousing over, it says system.double there. Any decimal number you put without a letter f is basically saying it's a double, but we're trying to save it as a float, so we have to use the letter f to make it happy. Alright, so anytime we refer to a float, we must put the letter f next to it. Now let's create a little method, a simple one. We'll do it at the end of this, and we'll just see how some of these variables work. So we'll just say, private, static. Notice I'm using the word static for all my methods here, and it's the same reason that we would have done this in Java when we were learning about methods at that point. We're just learning about one single class. So if we're going to use one class, and it has our main, and we're going to use methods next to that main, then it has to be static because we're not instantiating this object to get to those methods. So that's why we're using static here. All right, so we're going to say private static int, and we'll call it ref params. And we'll just pass in like int xyz. Right? So we'll take like xyz and just say plus plus, and just return XYZ. Right? Nothing new. We're not solving the space-time continuum or anything like that. We're just simply writing a boring little method here with a plus plus, and that's about it. And the way we just call this method is just to say z is equal to, ref params, and just pass in z again. So we know that we're just passing in our own variable and we're sending it back out with an increased value. Right? But what I want to draw your attention to is, so how would we actually print these values to the screen? Because the last exercise we did at the console, we did a simple console.writeLine, did a hello world. We didn't really get any further than that. And we learned that we learned in Java about doing system out println and printing stuff out to the screen. Well, we learned about printf as well, system out printf in Java, and that was a bit more of a trickier approach to displaying stuff on the screen. Well, with console.writeLine, we are taking that same trickier approach, but it's different from printf. And so if we were to print these variables to the screen, we would say console.writeLine, and we would pass in our text. So we'll say the value is now. But now if I want to print out both z and j to the screen, right? So in printf we would have placeholders like %, %d and %f. We would have done this, right? And then we would have done a comma. In fact, let me go full screen here so you can see it. So we would do this, and we would just say z and j, right? And that's how we would have done that here. Well, it doesn't exactly work this way in C#. Instead of doing like %ds and %f, so Microsoft's approach was, like, this is confusing stuff. Let's simplify it down, all right? Now, for you as programmers who have already done %ds and %fs and printfs, this might feel weird how we're going to do this. But if you were a newbie programmer and you were learning C# for the first time, this might make a little bit more sense because you haven't been exposed to %ds and %fs and so on. So we actually just specify the variable number in the list here. So we have z and we have j. These are two variables. This is considered variable 0, and this is considered variable 1 in a list. So we have an ordered list of 0 to n-1 variables that are inside our console write line. So instead of saying %d, we're going to say, using curly brackets, so opening curly, we're going to say 0 with a closing curly. That will represent the first variable, z. And then %f, we'll do curly 1. Right? So it might feel a bit weird, especially coming from the printf world, all right? But the idea is just to say we don't care about the type. We don't care that it's an int, float, or double. We're just saying that this is variable 0, this is variable 1. That's all we're saying. And so if we want to test this out, we can't forget that we have to put a console.read key, otherwise the program will disappear really quickly. So we'll say console.read key. And so now we can run this thing. Okay, and so my screen is changing, and this is the output I get. I know the text is really small, but essentially it's saying the value is now 16 and 2. All right, so that's what it's saying. All right, it did the plus plus, and then it also printed out the 2.0, essentially. All right, so nothing new. I mean, just the only thing that's new here is that we learned the ability to print to the console using console.writeLine. We've just recapped how to do a simple method, right? Nothing big here. But let's look into how we would use this new idea of an output parameter. All right? So we're going to create a method that will pass information out of the method. It'll actually pass multiple things out of this one method. What we're going to do is we're going to talk about this whole idea of normalizing. And we're going to normalize something down to a number between 0 and 1. The way normalizing works is that if you have a group of numbers, right, of any value, and what you do is you take the largest number of that group and you set that to be your base number. And you take every number in that group and divide it by that number. So that means the largest number of the group, when you divide it by itself, is 1, and everything else becomes 0 decimal something. So like a percentage almost of that number. All right, so let's create a method that will normalize our numbers. So, full screen again. So I'm going to say private static. This I'm going to say bool. Private static bool. This method is going to be called normalize point. All right? And we're going to take two numbers and pass this in. All right? So we're going to say int x and int y. All right? So we're passing two numbers in. And we're returning a Boolean. Now, the reason we return a Boolean is we're going to narrow down these numbers to be between 1 and 100. So any number that's greater than 100 or any number that's less than 1, we're just going to say this is no good for us. This is invalid. Even though normalization, you can use any number you want. Right? You can use decimal numbers to normalize. Right? But we're just going to add some constraint here just to test out the Boolean side of things of returning a Boolean. So anything greater than 100 or less than 1, we're going to return a false and say error, essentially. All right? So that's the purpose of the return. But we want to send back out the normalized numbers. So we actually have 3 returns in this one method. So this is our first return, the bool. But we want to return our normalized x and y. So we're going to say comma, and we're going to say out to represent an output variable. It'll be a type double. We'll call it x out. Okay? Call it x out. And then we'll create another variable or another argument. In fact, I'll put these output ones on a new line just so it's easier to read. And this second will be out double, and we'll say y out. Okay, so this will be y out. Now, there's 2 issues with this method off the bat. The first thing is we're not returning anything even though it's Boolean. So let's just make it happy and say return true. Meaning that if it gets all the way down to the end of the method, return true and it's happy. Okay? But it's not enough. Like even mentioning this is just saying, well, what's happening here when I mouse over this error is it's saying that x out and y out have not been assigned a value. So we can't return anything back out that way because it doesn't even know what to return. So we have to set a value for x out and y out no matter what. So it's going to throw this error until we fix that, even if we set it to 0. So let's do this. Let's set those values to 0 just to make this method happy. So we're going to say x out is equal to 0 and y out is equal to 0. Okay? All my errors have gone away. And now I can focus on coding up this method. Right? So the first check I want to do is to see if this value is between 1 and 100. So we'll throw in a little if statement and say if x is less than 1 or x is greater than 100, then we'll return false, meaning it failed. We'll do the same for y. If y is less than 1 or y is greater than 100, return false. Right? So we're doing those checks. But because we set x out and y out to 0, it still has something to return. Even though we're returning false here, we already set these values, so it's getting a return value no matter what. Okay, so we've satisfied the method no matter what, even though we're turning out early. Assuming we're happy with the numbers we've provided, we can go ahead and normalize these numbers. So let's start with checking to see which number is larger, because we don't know which one to normalize to until we know which one's the bigger number. So let's say if x was greater than y, meaning that x is the larger number, then we can go ahead and normalize. So what we'll do here is we'll say x out is equal to x divided by, and this kind of sounds silly, but this is the way we're going to do the normalization, because you can just set it equal to 1. We'll cast it to double and say x. And we'll do y out is equal to y divided by double of y. Now, of x. Now, the reason why we're casting x to double, we could have just casted these ones to double instead, right? But the issue here is that x and y are ints, and this is a carryover from Java, and an int divided by an int is still an int, even though we want to save it as double. So 9 divided by 5 becomes 1, right, instead of 1.8. So we cast one of them, it becomes an int divided by a double, so it saves it as double. Right, so that's why we're doing the casting here. Right? But in this case, we have now normalized. And here we really could have just said x out was equal to 1. It really is just 1. We know it, right? But just to be complete, we'll say x divided by x. Or rather, just for consistency. Otherwise, we know that y is bigger. So we're going to say x out is equal to x divided by, and then casting to double, y. And y out is equal to y casting to double to y. But either way, we have now normalized our numbers. Right? So now we've created this method. We've normalized numbers. Question now is, how do we use these methods? Because we know how to use a method normally, but now we have these additional parameters to work with here. And we're going to do that right now. So if we go back to main, just before read key, let's add in some code to actually call up this method. So let's declare a couple of ints. And we're going to pass those ints in. So we're going to say int x is equal to 55 and int y is equal to 64. We're just going to hard code these values. Won't bother asking for input. And we'll say double new x double new y. Now, if we want to call this method, let's put this inside an if statement just to see if it's true. We'll return that. We'll output the results. If it's false, we'll output an error message. So we'll say if normalize point. We're passing in x and y, and we want to pass in new x and new y. Right? We want to see if it's true. We know that we don't have to put equals equals true because it's the same idea. But it's still complaining. It's still complaining about new x and new y. And that's because it still expects to see the word out here. We actually have to say out new x and out new y. So out new x and out new y. And that will satisfy it. That'll satisfy it. So we can't forget the word new x and new y. Then we can do a console.writeLine. We'll just say the normalized point is, and before I enter those in, let's just say new x and new y. And then we'll put our placeholders in. So again, 0 to n minus 1, so we have new x is argument 0, new y is argument 1, so we'll use the curly brackets. So curly 0 and curly 1. Okay, so we can run this now by hitting start. So, again, tough to see at the back there, but it's saying the value is now 16 and 2, so it has the old stuff. But now it's saying the normalized point is 0.859375 and 1. We're expecting one of the values to be 1 no matter what, because it's the larger one, but it's saying that the other one's basically 85% of the second value. Right, that's really what it's saying. So 0.85, right, and 1. So we're going to add another class to this project, and we're going to learn how to add items now to Visual Studio so that this will become a really consistent thing, that this is the way you add new classes or new items to your projects. But if I want to add something, I'll just go to my Solution Explorer. I will right-click on W2 Ref Params, the project name, and I will say Add New Item. Now, anytime I want to add something to my project, I simply go that way. I just right-click on the project name, add new item. That's how I always do it. Now, in my case, I want to add another class. So I see class here at the top, Visual C# items. Make sure that's the correct language there. And then at the bottom, I will give it a name. And I'm going to call this thing person. So person.cs, so .cs for C#, but person is the name of the object I'm going to add. Hit add. And it has generated a new class for me. Now, I'm going to add two fields to this, first name and last name. So we'll start off by saying private string underscore first name, private string underscore last name. Right? So private string underscore first name, private string underscore last name. So two fields. Because they're private, we need to have a get and a set for them. Right? Okay, so we have first name and last name as our two variables. Let's add some getters and setters. So what we need to do is we'll do this right below. First name, we're going to say public string. I'm going to say first name with a capital F. First name. No semicolon. Opening and closing curly. Almost feels like a method call or a method definition. Right? So public string first name, I'm going to say get, open a curly, hit enter, and inside these curly brackets, for get, I'm going to say return underscore first name. And for set, so outside of the curly, I'm going to say set. Opening, closing curly. And I'm going to say underscore first name equals value. All right? Looks a little weird. All right? Almost kind of makes you wish you just could do it the old way, where you just declared your method declaration the long way, right? But this shortcut, once you understand it, actually is a bit quicker to work with. All right? So we've declared our variable underscore first name. It's private. But then we're going to say public string and something else, like first name with a capital F. So this almost feels like a method declaration. Almost. We don't have any round brackets here. Right? Instead, we have curly brackets. And within the curly brackets, we're going to define our getter. So we have a keyword called get. This is basically saying this is my get method. And within the curly brackets, all I'm going to do is just say return underscore first name. So underscore this value, or this variable. Right? The set, I'm going to say first name equals value. Now, value is a keyword. Because we're always, when we're setting something, we're always setting it, we're always passing something in. We have to make up that variable name. Well, Microsoft decided we'll just standardize it with like one keyword. Right? Value is always implied to be the variable that's being passed in. Okay? So that's how we always define a getter and setter inside C#. So we did this for first name. Let's do the same thing for last name. So I have private string last name. So I'm going to say public string last name with a capital L. No semicolon, just go straight into the opening, closing curly. Define get. And you know, if I'm even more savvy, I might, instead of using all these extra blank lines, I could just say return underscore last name. In fact, you might see this more often. Set and say underscore last name equals value. All right, that should shortcut a lot of code for you. So this actually looks like one method definition right here, as opposed to creating two method definitions inside Java. All right. Now, let's actually use this. So we'll jump to program.cs. And let's call this. All right, so we'll go back to main up here, and let's declare a person object. So we're going to say person p is equal to new person. And I want to set first name and last name. So we would normally have said p.set first name, p.set last name. We would have said that, but we don't have to do that anymore. Now we just say p.first name is equal to Jim, and p.last name is equal to Kirk. So this is like saying set first name, and this is like saying set last name, except we're just using it as regular variables. How coding was meant to be done. Right? Just simply use the variable. Like, why go through this headache of get and set? And if I want to print this out to the screen, let's use a console write line to print it back out. So we'll say console.writeLine, and we'll pass in the name is. And before I go in with the placeholders, let's actually list them out. We'll say p.firstname, p.last name. Right? See how I'm just using them as if they are variables? I've got a comma there. And I'll use my placeholders, so curly 0, space, and curly 1. Right? See, I'm using p.firstname, p.last name as if it was nothing. Right? As if there were no gets and sets involved. Okay, so save this. Okay, well, let's run this just to see what it looks like. So I'm going to put this down here, hit the start button. And now you should see this third line that says the name is Jim Kirk. Right? Our variables were private, but we still had access to the first name and last name without using get first name and get last name and set first name and set last name. So that's how we use gets and sets now in C#. All right, so going back to person.cs, and I'm going to full screen this so it's easier to read. Right? So we created first name and last name. Right? We created the get and set, so we really simplified it. But what if we wanted to have the full name? All right? So what if we wanted to do the person's full name? Well, we did the person's full name in main. We just said first name plus last name, or just first name and then last name separate. But what if we want to have another variable that had the entire full name at our disposal? So what if we said just public string full name? I'm not even going to create a variable. I don't need a variable for this. I don't need an internal variable. So I'm just going to say full name. And what if I did a get? Right? I could return this dot first name plus this dot last name. And to really be proper about it, maybe put a space in between. So now what I want to bring to your attention here is that we now have a getter and setter for full name. We don't have an internal variable because we don't need it. Right? We don't need to have something called full name separate, because all we're just doing is taking first name and last name and returning it back. But one thing I want to point to you here is that I'm not doing a set. I'm only doing a get. And so with this get on its own, I'm basically saying this variable is read-only. I cannot overwrite full name because there's no set. But why would I? Because there's no full name variable to override. So what's the point? Even if I did a set over here, I have to manually update first name and last name separately, which is kind of strange, right? So just having this get on its own is now telling the compiler that this is read-only. So I cannot overwrite this value. And to prove that, let's actually try that out. Let's go into main and try and play with this value here. So what I could say, or I could try saying here is p dot full name. Now first of all, there's no option to say full name here. But if I said full name is equal to just the letter S, let's see what happens here. And I get an error. Right? If I mouse over, it says property or indexer person.fullname cannot be assigned to it is read only. So it says it right there. It is read only. Right? So I cannot overwrite it because there's no setter. Right? But let's try using it because we created a getter. So we could say console.writeLine full name is, and then just do a curly 0, and then just do a p dot full name. That's available. Right? So that's available. Right? So we can retrieve from it, we just can't write to it. Okay, and you can try running this. So we'll save this and run it and see what it looks like. And it should just come out to be the same result as above. So it says full name is Jim Kirk. Right? So it says full name is Jim Kirk. Same result as the other one. But now you have a getter to retrieve that for us automatically. Alright, so for this next exercise, we're going to add a new class. So we're going to right-click on our project name, W2RefParams, and say add new item. Again, so we're adding a new class. So we'll look at class, Visual C# items. We're going to call this one complex for complex numbers. So the real and imaginary. And we'll hit add, and we'll have a new class called complex. Now, we're going to define a couple of variables here inside of this, and we'll do the gets and sets as well. So we'll say private int real for the real number, and we'll say private int imaginary for the imaginary number. Okay? And we're going to do the same get and set that we just did a moment ago for the person object. We're going to do the same approach here for the real and imaginary numbers as well. We'll make them both read and writable. So right below real, I'm going to say public int real with a capital R, and do my opening and closing curly. And so I'm going to say get opening curly and just say return real with a lowercase r, and set opening curly real equals value. Right? So this is my getter and setter for the real variable. And I'm going to do the same thing for the imaginary variable. So I'm going to define public int imaginary with a capital I, opening and closing curly, say get return imaginary and set imaginary equals value. Okay, so I have my get and my set for real and imaginary. Okay, so we have our two variables. Real imaginary, we have getters and setters. Now, let's start by creating a constructor. So we'll create a constructor to illustrate the issue we talked about earlier in the lecture about being able to overwrite constructors and stuff. So we're going to illustrate that as well. So we're going to say public complex. We'll pass in int r and int I. And we'll just say real is equal to r, imaginary is equal to I. Right? So we create a constructor there. But let's get into overriding the plus and the minus. So suppose we had two complex numbers and want to add them together. Well, normally our thought might be to just create a method to join the separate parts together, piece by piece. But there's no point in that if we can overwrite the operator to do this for us automatically. So the way we would overwrite the addition operator is to say in a new method, public static complex. So we're returning the same type of the class. So public static complex. Then we say operator to tell it, hey, we're doing an operator here. And we'll do the addition one. So we'll say plus. Now, we have to pass in some arguments here. So if we were to say a plus b, we have to provide a and b in the round brackets. That's what we're doing now. So we're going to say opening round bracket. We're going to say complex C1 and then complex C2. Right? So we're going to say complex C1 and complex C2. And so what we're doing here is we are providing, if we're going to say a plus b, we're passing in a and b, but we also specify the type. So if we're joining a plus b and a plus b are complex numbers, then we have to say complex a and complex b. Right? That's what we're saying here. So we're saying complex C1 and complex C2. Now, I want to do my addition, so now I'm going to go ahead and do it. But what I'm going to do is I'm going to generate a new temporary variable, a temporary complex variable. So I'm going to say complex, new complex is equal to new complex. But here's an issue. There is an issue here. So I can't do this because it's complaining that there is no default constructor. There's only complex with an int and an int. So I have to create an empty constructor because by default we would have auto-generated this. It always auto-generates constructors. And in old versions of C# it did this, but now in newer versions it took it away. So right below it, I'm going to say public complex, nothing inside of it, and just set them to 0. So real equals 0, imaginary equals 0. Right? So now the error goes away. I still have the error for the plus sign because I haven't returned anything. So that's okay, right? That's fine. But now I have to actually physically generate that default constructor now, just to make it happy. So now that I've said new complex, let's add things together. So let's say new complex dot real is equal to C1 dot real plus C2 dot real. And do the same for imaginary. Right? And then just return it. Return new complex. So we would have probably created a new method. We probably would have done all this work, right? But we don't need to. We don't need to. And before we implement this code, let's do the same thing for minus. So we'll do this again with the minus. We'll say public static complex operator minus, and pass in C1 and C2, so complex C2. All right, we'll go through the same motions again, declare a temporary variable. We'll subtract this time, so new complex dot real equals right, and just return new complex. Okay, so let's take this and let's use this. So we're going to move over to main and actually instantiate some variables here. So going back to program.cs. After our person example, let's create a couple of complex numbers. We'll make up some numbers. So we'll say complex num1 is equal to new complex. We'll just pass in 3 and 4. So this is like saying 3 plus 4i. And then complex num2 is equal to new complex. And we'll say 4 and 5. So 4 comma 5, which is like saying 4 plus 5i. Now I want to add these two together, so I'll declare a new one. Let's say complex, call it num3 equals new complex, right? And all I'm going to say is num3 is equal to num1 plus num2. I have now just added two objects together. So these objects have a number of variables inside of them, real and imaginary. And so now it's going to execute that plus method that we just overwrote. Right? So we just overwrote the plus operator. It's going to execute that method. And it's going to go in, it's going to add the real, it's going to add the imaginary separately, and send back a number with the real and imaginary. And to prove that it's done that, let's print out the value. So let's do a console.writeLine. And say the complex number is, and we'll do the curlies after, so we'll say num3.real, num3.imaginary. And we'll put in our little curly 0, curly 1. And we could format it a bit better by using letter I or J and use the plus number and the plus symbol inside of there, but we'll leave it. In fact, let's do minus. Let's say num3 equals num1 minus num2. And just do the same console write line. Just copy and paste it. So let's run this now. And let's prove that it's actually added and subtracted. Okay, so the numbers we have are 3 plus 4i and 4 plus 5i. And so the complex number is now 7 and 9. So 3 plus 4 is 7, 4 plus 5 is 9. So this is saying 7, 9. So it did the addition correctly. Now we did a subtraction. So it's saying it's minus 1, minus 1. So we're saying 3 minus 4, which is minus 1. 4 minus 5 is minus 1. So it correctly did the subtraction as well. Okay, so let's do one more example of this. So let's leave the complex number. Okay, let's create one more class. So we're going to leave the complex number. We're going to right click. We're going to add a new item. It'll be a class. I'm going to call it point, as in XY point. So now I have point.cs. My class is called point, but we did a lot of extra code in there, and we're gonna take that away. We're gonna simplify this down to something a little more leaner, right? So I did things a long way in the complex example just to show you things literally how things were happening, but I want to simplify the code a bit more. So we're gonna have still two variables. So we'll say private int x, private int y. We're going to do the gets and sets. So we'll say public int, I'm going to say capital X, and do the gets and sets. So get return x, set x is equal to value, and do the same thing for y. So we'll say public int y capital, and say get return lowercase y, and set y equals value. Right? So we just did our getters and setters again. Alright, nothing new there. But we're going to delve straight into simplifying this code. We're still going to do an addition and subtraction again, so we'll still do the plus and minus. But let's create our constructor. So we'll just say public point and pass in int x and int y. And we'll say capital X is equal to x. Or better yet, this may get confusing because we have the same variable we're reusing. So let's just be specific about it and say this dot x is equal to x. Keep it lowercase. This dot y is equal to y. So we won't bother with the getters. We'll just go direct to the variable. Now let's overwrite these operators. So I won't bother with the default constructor because I don't need it. So I'm going to go straight into doing a public static point operator plus. Pass in the 2 point variables. So point, say p1, point p2. But I don't want to go through that whole hassle of, declaring all these new variables. So let's just go straight to the return statement. Say return new point of p1.x plus p2.x, comma p1.y plus p2.y. I could have done this. Instead of those extra lines of code in the complex example, I could have just simplified it down to this. And for the minus, I'll just do the same thing. Just going to copy it this time and paste it. Change it to minus. And then just do P1x. Just change the pluses to minus. Oops. And so now I have my plus and my minus. So moving back to main, after we save this, go back down. We have a lot of code here, so let's go down to just before console.readKey. Let's declare a couple of points. So we'll say point P1 is equal to new point, and we'll just say like 8 and 9. P2 we'll say that this is 10 and 15. And we'll say point P3 is equal to P1 plus P2. And we could have done the minus here as well, and we'll leave the minus. We'll just go straight into the plus. And we'll say console.writeLine and just say the point number is, and we'll do curly 0 and curly 1. We're going to print out the x and the y. So this will be P3 dot capital X, P3 dot capital Y. Okay, so let's run this. And see this final piece in action. Alright, so the last line that it says here is the point number is 18 and 24. So we said 8 plus 10, which is 18. 9 plus 15 is 24. So essentially what we did here was we investigated dealing with method calls and getting more specific about how C# does things and how it differs from Java. So one of the things was the getters and setters. We simplified getters and setters down. We learned how to work with console.writeLine. We learned how to override operators, so plus and minus. We learned about the default constructor when it's not defined, causes some issues, among other things.